Exercise 8.3, problem 16, discussion. Okay, let's read the problem. A cylindrical bucket of height 32 cm and radius 18 cm is filled with sand. The bucket is emptied on the ground and a conical heap of sand is formed. If the height of the conical heap is 24 cm, find the radius and the slant height of the heap. Good. So let's mark what is given in the problem. Okay, cylindrical bucket. Height of it is 32 cm. Radius is 18 cm. It's full of sand. Okay. This bucket is emptied into a conical heap of sand. The height of the cone is 24 cm. Okay, that's it given. So let's write it. Height of the cylinder is 32 centimeters. Radius of the cylinder is 18 cm. Height of the cone is 24 cm. So what are we asked to calculate? We are asked to calculate the radius and the slant height of the heap, that is of the cone. Okay. So we are asked to calculate radius and the slant height of the cone. So what is the formula? Let's list the formula. Volume of the cylinder is pi r squared h. Volume of the cone is 1/3 pi r squared h. The slant height is given by root of r square plus h square. Now, if you see r is not known, so which means volume of the cone cannot be calculated. But whereas everything is known for the cylinder, so volume of the cylinder can be calculated. But we know this cylinder volume, which is a bucket here, okay. Actually, it's height of the cylinder, it should be height of the bucket. Cylindrical bucket, okay, I made a mistake here. It's a cylindrical bucket. So, volume of the bucket or the cylindrical bucket is equal to volume of the conical heap. So, which means pi r squared h will be equal to 1/3 pi r squared small h. So, the key is the volume of the sand in cylindrical bucket equal to volume of the sand in the conical heap. Because it's the same sand, whatever is in the bucket is getting transferred, it's just put on the ground. So, the volume of the conical heap will be exactly equal to the volume of the sand in the bucket. It's only getting transferred from cylinder. It is going to become a cone because it is thrown on the ground. So, volume is not lost. Okay, so it will be the same volume. So, using that condition, you know the volume of the cylinder is pi r squared h equal to 1/3, which is that of the cone is 1/3 pi r squared h. Capital R and capital H refers to cylinder. Small r and small h refers to cone. You got it? So, here everything is known except r. So, r can be calculated. Once you know r, then a slant height of the cone can be calculated because h is already given here. H is 24 cm for cone. Radius you are calculating it in this step. So, put that value and you will be able to get the value of the slant height. Okay. So, let me summarize the steps. So, let r and L be the radius of the radius and the slant height of the cone. Equate the volume of the sand in the cylindrical bucket to the volume of the sand in the conical heap and simplify to get this equation pi r squared h equal to 1/3 pi r squared h. Step 3. Substitute the values of the cylinder, that is capital R and capital H is that of the cylinder and the small h is of the cone. These are all given in the problem. Substitute all those values here and simplify. You will be able to get the value of the radius of the cone. Okay. Once we know the cone's radius, then we can substitute the value of the cone's radius and the cone height in this formula for slant height and calculate the slant height of the cone. I got it? I think that's all in this problem. So what I suggest is pause the video here and try to do the problem on your own. Once completed, come back and check you are working with our solution. Okay, the solution of the problem is here. As usual, we are listing out what is given. Given height of the cylindrical bucket is 32 cm. Radius of the cylindrical bucket is 18 cm. Height of the conical heap is 24 cm. This is small h. Capital letters are for the cylinder. Small letters are for the cone. So, let r be the radius. We don't know that. Let L be the slant height of the cone. All we know is volume of sand in the cylindrical bucket is exactly equal to volume of the sand in the conical heap. So you write the formulas. Cylindrical bucket is pi radius square and into h of the cylinder. For the cone, it is 1/3 into pi radius square of the cone into height of the cone. Okay, now we know this value, so substitute these values. R is 18. Okay, the radius of the cylinder is given here 18. So 18 into 18 into 32 is the height of the cylinder. So substitute that here. Will be equal to 1/3 into pi into radius of the cone. We don't know. H, height of the cone, is given here 24 centimeter. So substitute that here. This on simplification, R square will be, pi and pi will get cancelled. Okay, will be 18 into 18 into 32. Okay, this 3 will go up and 24 will come down. If you see 18 into 18, we can retain. 8 will go 3 times here and that 3 will get cancelled, and 8 is going 4 times here. So it becomes 18 into 18 into 4. That is R square. So R will be 18 is taken out. Square root of 4 is 2. So 18 2s are 36. So this is the radius of the conical heap. Okay, half the problem is done. What else? We are asked to calculate the slant height of the cone. So we have done radius. We have to calculate slant height of the cone. The formula for the slant height is L equal to R square plus H square. R we just calculated it to be 36. H is already given in the problem 24. Okay, so 24 square is 576. 36 square is 1296. This on addition gives you 1872. The slant height is square root of 1872. This is factorized as 2 into 2 into 2, 4 2's and 9 into 13. You got to do the small division method and factorize it. Okay, once that is done, so 4 2's are there, so 2 2's can be taken. Square root of 9 is 3, and square root of 13 is not it's not a whole number, so we'll keep it as square root of 13. So this becomes 2 2's are 4, 4 3's are 12. It is 12 root 13 centimeter. So the radius of the cone is 36 centimeter, which we calculated earlier, and the slant height is 12 into root 13 centimeter. You got it? So the key is the volume of the sand in the bucket is exactly equal to volume of the sand in the cone. Once you have that key principle clear and substitute the right formula, then it is very easy to finish the problem. Okay, I hope you got this answer correct and the working also right. If not, please check where you have gone wrong and make suitable corrections. Okay, if you have not understood the concept, please go back to the discussion part of the video and review it. Thank you for watching.